The liar paradox. Can truth contradict itself? Imagine reading a statement that says, "This statement is false." You pause, trying to make sense of it. If the statement is true, it must be false. But if it's untrue, it must be true. This simple sentence throws logic into a loop, creating a paradox that has puzzled philosophers and logicians for centuries. This is the liar paradox, a riddle at the intersection of truth, language, and logic. At first glance, it seems like a playful wordplay exercise. But beneath its surface, it poses a profound challenge to our understanding of meaning and reality. The paradox unveiled, a battle of truth and falsehood. The liar paradox begins with a deceptively simple premise, a statement that refers to itself in a contradictory way. At its heart, it is a clash between truth and falsehood, a logical tug-of-war with no clear winner. The contradiction. If the statement, "This statement is false," is true, it must be false because that's what it claims. But if it's false, it must be true because it accurately states its falsehood. The infinite loop, the paradox, creates an endless loop where truth and falsehood chase each other in circles. It defies resolution, leaving us stuck in a logical limbo. The broader implications, the liar paradox, raises questions about the nature of truth. Can something be both true and false? Does it reveal a flaw in our use of language and logic? Self-reference, the core of the paradox. At the heart of the liar paradox is self-recognition, where a statement or system refers to itself. While self-recognition can be helpful and even necessary in specific contexts, it can lead to contradictions that defy resolution. Examples of self-reference. Consider a dictionary definition of self-referential as a word that refers to itself. While this definition makes sense, it also highlights how self-reference can be circular. Another example is the phrase, "I always lie." If the speaker is telling the truth, they lie, creating a self-referential paradox. The power and danger of self-reference, self-recognition, is a key feature of many logical systems, from mathematics to computer programming. However, it can also lead to inconsistencies and contradictions, as seen in the liar paradox. Modern implications, Gödel, Turing, and paradox in systems. The liar paradox is not just a linguistic curiosity. It has profound implications for mathematics, computer science, and philosophy. It reveals the limits of formal systems and the challenges of achieving complete consistency. Gödel's incompleteness theorems. Mathematician Kurt Gödel demonstrated that any sufficiently complex logic system is inherently incomplete. It cannot prove all truths within its framework. The liar paradox inspired Gödel's work, as it showed that self-referential statements can create unresolvable contradictions. Alan Turing and the halting problem. Computer scientist Alan Turing built on Gödel's insights to explore the limits of computation. He proved that there are problems that no algorithm can solve, such as determining whether a program will ever halt or run forever. This halting problem is another form of paradox rooted in the challenges of self-reconcile. Artificial intelligence and logic, the liar paradox, also raises questions about artificial intelligence. How can AI systems navigate contradictory information or statements that refer to themselves? Ensuring logical consistency in AI remains a significant challenge. Philosophical reflections on truth and meaning. The liar paradox is more than a logical puzzle. It is a philosophical challenge to our understanding of truth and meaning. What is truth? The paradox forces us to reconsider the nature of truth. Is truth an absolute property, or is it context-dependent? Can truth exist independently of language, or is it shaped by how we communicate? The limits of language. Language is a powerful tool, but it is also imperfect. The liar paradox highlights language's limitations, revealing how easily words can become entangled in contradictions. This raises broader questions about the reliability of human communication. Can we ever fully trust the words we use to describe reality? Paradoxes in everyday life. The liar paradox is not just a theoretical problem, it has echoes in everyday life. Think of moments when someone says, "I'm fine," but their tone suggests otherwise. Truth and meaning are often more complex than they appear. Reflections on the liar paradox. The liar paradox reminds us that truth is not always straightforward. It challenges us to think more deeply about the nature of logic, language, and reality, revealing the complexities beneath the surface of even the most straightforward statements. As we continue our journey through paradoxes, let us carry with us the lessons of the liar paradox. That questions are often more powerful than answers, and that the pursuit of truth is as much about embracing uncertainty as it is about seeking clarity. The grandfather paradox: can you erase yourself from existence? Time travel has captivated the human imagination for centuries. From H.M. Wells' The Time Machine to blockbuster films and speculative science, the idea of moving through time is as thrilling as it is perplexing. But with the allure of time travel comes a host of paradoxes that challenge our understanding of causality, free will, and the fabric of reality itself. The grandfather paradox is one of the most famous and confounding. It asks a simple yet profound question. What happens if you travel back in time and prevent your birth? If you succeed, you erase your existence. But without your existence, how could you have traveled back in time in the first place? This paradox forces us to confront the nature of time, cause and effect, and the possibility of alternate realities. The core of the paradox. Time and causality collide. The grandfather paradox arises from a clash between two fundamental principles of reality: causality and the possibility of altering the past, causality and the chain of events. In our everyday experience, events unfold linearly, causes precede effects, and actions have consequences. For example, your grandparents meet, fall in love, and have children. Those children eventually lead to you. This chain of events defines your existence. The time traveler's dilemma. If you were to travel back in time and prevent your grandfather from meeting your grandmother, you would break this chain. Without their union, you would never be born. But how could you have traveled back in time to intervene if you were never born? The paradox creates a loop of cause and effect with no clear resolution. Theoretical resolutions to the paradox. Over the years, physicists and philosophers have proposed various resolutions to the grandfather paradox. While none are definitive, each offers a fascinating glimpse into the possibilities of time travel. Self-consistency principle 1. Proposed resolution is the Novikov self-consistency principle, which suggests that past events are fixed and cannot be changed. According to this view, any actions you take in the past are part of history. For example, if you attempt to prevent your grandfather's meeting, your efforts will fail, ensuring the timeline remains intact. The multiverse hypothesis. Another possibility is that time travel creates branching timelines, where changes to the past result in alternate realities. In this scenario, preventing your grandfather's meeting would create a new timeline in which you do not exist while your original timeline remains unchanged. You would continue to exist in the new timeline as a visitor from the original one. Closed time-like curves. Some theoretical physicists propose the existence of closed time-like curves, paths through space-time that loop back on themselves. These curves allow time travel within self-contained loops, where paradoxical events resolve themselves through the loop's constraints. Time travel in popular culture. The grandfather paradox has inspired countless stories as a narrative device to explore the complexities of time and causality. Back to the Future. In this classic film, Marty McFly accidentally prevents his parents from meeting, threatening his existence. The story revolves around his efforts to restore the timeline and ensure his birth. Doctor Who, the long-running series, frequently grapples with time travel paradoxes, exploring the moral and practical consequences of altering the past. Tenet, Christopher Nolan's Tenet, introduces the concept of time inversion, in which characters move backward through time. The film delves into the interplay between the past, present, and future, creating a complex web of events. Philosophical implications of the grandfather paradox. Beyond its scientific implications, the grandfather paradox raises profound philosophical questions about the nature of time, free will, and identity. Is time fixed or fluid? The paradox challenges us to consider whether time is a fixed sequence of events or a fluid, malleable construct. What happens to our sense of continuity and identity if time can be altered? The nature of free will. The grandfather paradox raises questions about free will. If one's past actions are constrained by the need to preserve the timeline, is one truly free to make choices? Conversely, if you can change the past, does that imply a lack of determinism in the universe? The meaning of existence. The paradox forces us to confront the fragility of our existence. If a single event in the past could erase us from reality, what does that say about the nature of being? Reflections on the grandfather paradox. The grandfather paradox reminds us that time is not a simple, linear thread, but a tapestry of interwoven events, connections, and possibilities. It challenges our understanding of cause and effect, forcing us to think beyond the constraints of logic and embrace the mysteries of existence. As we continue our journey through paradoxes, let us carry the lessons of the grandfather paradox. That time is both a boundary and a bridge, a mystery that connects us to the past, present, and future in ways we are only beginning to understand. Zeno's paradoxes. Can motion be an illusion? In our daily lives, motion seems simple and intuitive. We walk, run, and watch objects move without a second thought. But what if motion were an illusion? A concept that defies logic when examined closely. This is the question raised by Zeno's paradoxes, a collection of thought experiments from ancient Greece that challenge our understanding of space, time, and motion. Proposed by the philosopher Zeno of Elea in the 5th century BCE, these paradoxes reveal the hidden complexities of seemingly straightforward phenomena. Zeno's paradoxes are more than philosophical riddles. They profoundly challenge our perception of reality. They force us to question the nature of continuity, infinity, and change, inviting us to reconsider what we think we know about the world. Achilles and the Tortoise, a race that cannot be won. One of Zeno's most famous paradoxes, Achilles and the Tortoise, begins with a simple premise. Achilles, the swift Greek hero, challenges a tortoise to a race. To make it fair, Achilles gives the tortoise a head start. The paradox. When Achilles begins running, he must first reach where the tortoise started. But the tortoise has moved a bit farther ahead by the time he arrives. This process repeats endlessly. Every time Achilles reaches the tortoise's previous position, the tortoise has advanced slightly. Zeno says, this infinite sequence means Achilles can never overtake the tortoise. The infinite division of space. The paradox highlights the idea that space can be divided infinitely. Between any 2 points, there are always smaller and smaller distances to cross. If every step Achilles takes requires crossing an infinite number of smaller steps, how can he ever reach the tortoise? The resolution. Modern mathematics resolves this paradox through the concept of infinite series. While the sequence of steps is endless, the total time required to complete them converges to a finite value. This mathematical insight reveals that infinity is not an obstacle to motion, but a property of how we measure it. The dichotomy paradox. Can you ever begin? Another of Zeno's paradoxes, the dichotomy paradox, asks whether it is possible to begin moving. The paradox. Before reaching any destination, you must first travel halfway there. But before reaching the halfway point, you must travel halfway to that point. And so on. This creates an infinite sequence of smaller and smaller distances to cross. How can you ever begin moving if motion requires completing this endless sequence? The nature of infinity. Like Achilles and the tortoise, the dichotomy paradox highlights the infinite divisibility of space and time. It forces us to grapple with the idea that even the most straightforward actions involve traversing endless steps, mathematical insights. The paradox is resolved by understanding that infinite sequences can have finite sums. For example, the endless series 1/2 plus 1/4 plus 1/8 plus adds up to 1. This mathematical framework shows that infinite processes can be completed in finite time, allowing motion to occur. The arrow paradox is motion an illusion. The arrow paradox challenges the very concept of motion by questioning whether an object in motion can ever truly move. The paradox. At any given moment, an arrow in flight occupies a specific position in space. In that instant, it is not moving. It is simply there. If every moment in time is like this, where the arrow is stationary, how can motion ever occur? Time is a series of moments. Zeno's argument relies on the idea that time comprises individual, discrete moments. Motion becomes an illusion if each moment is static, a series of still images rather than a continuous flow. Modern interpretations. Physicists and philosophers have debated whether time is continuous or discrete. While classical physics treats time as a smooth continuum, some modern theories suggest that time may have a granular structure at the quantum level. Philosophical reflections on Zeno's paradoxes. Zeno's paradoxes are not just mathematical puzzles. They are profound challenges to our understanding of reality. The nature of continuity. Zeno's paradoxes force us to question whether space and time are continuous or made up of discrete units. Is reality a smooth flow or built from countless indivisible pieces? The limits of perception. Zeno's paradoxes distort our intuitive perception of motion and change, revealing their hidden complexities. They remind us that reality is often more intricate than it appears. Infinity in the human mind. Zeno's paradoxes highlight the difficulty of grasping infinity. They show us that our minds struggle to reconcile the infinite with the finite, leaving us in awe of the universe's boundless complexity. Reflections on motion and change. Zeno's paradoxes remind us that motion, change, and progress are not as straightforward as they seem. They challenge us to think deeply about the nature of reality and reveal the hidden layers of complexity beneath everyday experience. As we continue our exploration of paradoxes, let us carry with us the lessons of Zeno's riddles, that even the simplest truths can lead to infinite questions, and that the journey of understanding is as limitless as the universe itself. The omnipotence paradox. Can an all-powerful being have limits? What does it mean to be all-powerful? The concept of omnipotence, the ability to do anything without limit, has fascinated philosophers and theologians for centuries. Yet, when examined closely, this seemingly simple idea reveals a profound paradox. The omnipotence paradox asks a deceptively straightforward question. Can an omnipotent being create a stone so heavy that they cannot lift it? If they can make such a stone, then there is something they cannot do, lift it. But if they cannot create the stone, there is also something they cannot do, create the unliftable object. Either way, it seems that omnipotence is contradicted. This paradox challenges our understanding of power, logic, and the very nature of possibility. Is omnipotence an achievable concept, or is it inherently self-contradictory? The paradox unveiled. Power versus logic. The omnipotence paradox is centered on a tension between power and logical consistency. It forces us to question whether omnipotence can exist without contradicting itself. The core contradiction. Omnipotence is often defined as the ability to do anything, but the paradox reveals a logical trap. If an omnipotent being can create the stone, they are not omnipotent because they cannot lift it. If they cannot make the stone, they are not omnipotent because they lack the power to create it. The limits of logical possibility. Some argue that omnipotence does not include the ability to do the logically impossible. For example, creating a square circle or a married bachelor is not a limitation of power, but a reflection of the inherent contradictions in the concepts themselves. By this reasoning, creating a stone so heavy that it cannot be lifted might fall into the category of logical impossibilities, which do not diminish omnipotence. Philosophical interpretations of omnipotence. Philosophers and theologians have debated the nature of omnipotence for centuries, offering various interpretations to address the paradox. Absolute omnipotence. In this view, omnipotence means the ability to do anything, even the logically impossible. This interpretation embraces the contradiction, suggesting that an omnipotent being could create and lift the unliftable stone, even if this defies logic. Critics argue that this definition renders the concept incoherent, allowing for contradictions that undermine the idea of power. Logical omnipotence. Another interpretation defines omnipotence as the ability to do anything logically possible. Under this framework, the paradox dissolves because the task itself, creating a stone too heavy for an omnipotent being to lift, is a logical impossibility. This interpretation preserves the coherence of omnipotence while acknowledging the limits of logic. Omnipotence as maximal power. Some philosophers redefine omnipotence as maximal power, the ability to perform any action, meaningful action, within the constraints of reality. This view shifts the focus from abstract contradictions to practical expressions of power, emphasizing the meaningfulness of actions rather than hypothetical paradoxes. Omnipotence in theology and culture. The concept of omnipotence is deeply rooted in theology and culture, where it often serves as a symbol of ultimate authority and power. Omnipotence in religious thought. Many religious traditions attribute omnipotence to deities, describing them as creators and sustainers of the universe. In monotheistic traditions, omnipotence is often paired with omniscience, all-knowing, and omnipresence, present everywhere, forming a triad of divine attributes. The omnipotence paradox raises questions about the nature of divine power. Does logic bind it, or does it transcend human understanding? Omnipotence in literature and mythology. Stories of gods and supernatural beings often explore the limits of power. In Greek mythology, for example, the Fates challenge Zeus's authority, representing forces beyond his control. In modern literature and film, characters with godlike powers, such as Dr. Manhattan in Watchmen, grapple with their abilities' ethical and existential implications. Omnipotence in popular culture. The paradox has inspired countless discussions in science fiction, where omnipotent beings like Q from Star Trek or the Celestials from Marvel Comics use their powers to challenge our understanding of morality and logic. Philosophical reflections on power and limits. The omnipotence paradox is not just a question about divine power. It reflects the nature of power itself. It challenges us to consider the relationship between ability, limitation, and meaning, the role of limits. Paradoxically, limits can give power its meaning. For example, the ability to create something beautiful or meaningful often depends on constraints that shape the creative process. The paradox suggests that omnipotence might not be about doing everything, but about doing what matters. The ethics of power. The paradox also raises ethical questions. What responsibilities come with ultimate power? If power has no limits, does it risk becoming destructive or meaningless? These questions resonate not only in theology, but also in politics, leadership, and personal relationships. The mystery of the infinite. Ultimately, the omnipotence paradox reminds us that concepts like infinity, omnipotence, and perfection may be beyond human comprehension. It invites us to embrace the mystery and wonder of existence, even as we strive to understand it. Reflections on omnipotence and paradox. The omnipotence paradox is more than a riddle. It is a mirror that reflects our most profound questions about power, logic, and the nature of existence. It invites us to explore the boundaries of what is possible and to consider how limitations shape the meaning of our actions. As we continue our journey through paradoxes, let us carry with us the lessons of the omnipotence paradox, that power is not just about what we can do, but about what we choose to do, and that even the most infinite concepts contain mysteries worth pondering. The paradox of the infinite. Can infinity be understood? Infinity, a concept that is both captivating and overwhelming. From the boundlessness of space to the intricacies of mathematical sequences, infinity surrounds us, shaping our understanding of the universe. Yet, when we try to grasp its true nature, we face paradoxes that defy logic and intuition. The paradox of the infinite is not a single puzzle, but a collection of questions that challenge our understanding of size, scale, and quantity. It asks, can something be both infinite and finite? Can we genuinely comprehend the unending? Or is infinity a construct of our imagination? Through the lens of mathematics, philosophy, and cosmology, the paradox of infinity invites us to explore the boundaries of thought itself. Hilbert's Hotel, a paradox of infinite rooms. One of the most famous illustrations of the paradox of infinity is Hilbert's Hotel, a thought experiment proposed by mathematician David Hilbert. The setup: imagine a hotel with infinite rooms, each occupied by a guest. Despite being full, the hotel can still accommodate new guests. How? By shifting the occupant of room 1 to room 2, room 2 to room 3, and so on. This frees up room 1 for the new guest, even though every room was already full. The paradox. Hilbert's Hotel demonstrates the counterintuitive nature of infinity. Unlike finite numbers, infinity does not behave in ways we expect. For example, adding or subtracting from infinity still leaves infinity. An infinite hotel can accommodate infinitely more guests, even when full. The implications. The paradox highlights the strange properties of infinite sets, which are studied in mathematical fields like set theory. It also raises philosophical questions about the nature of existence. Can something infinite ever be complete? Infinite regress. When does it end? The concept of infinite regress arises when a chain of reasoning or causality stretches endlessly, with no clear starting point. Examples of infinite regress. In philosophy, infinite regress appears in questions like, who created the creator? If every cause has a cause, where does the chain begin? In science, infinite regress can occur when explaining the universe's origin. What caused the Big Bang and what caused that cause? The paradox, infinite regress, challenges our desire for definitive answers. It suggests that some questions may lead to endless whys without ultimate resolutions and interpretations. Some philosophers argue that infinite regress is not a problem, but a feature of specific systems where the chain holds meaning. Others propose that infinite regress must terminate at a first cause or fundamental truth, beyond which no further explanation is needed. The infinite in mathematics and cosmology. Infinity is a central concept in mathematics and cosmology, where it reveals the beauty and complexity of the universe. Infinite series in mathematics. Infinite series allows us to sum infinitely many terms to arrive at a finite value. For example, the series 1/2 plus 1/4 plus 1/8 plus converges to 1. These series demonstrate how infinity can coexist with finiteness, defying our intuition. Fractals. Infinity in patterns. Fractals are shapes that exhibit infinite complexity, repeating their patterns at smaller and smaller scales. Did you know that the length of a coastline can be considered infinite when measured at increasingly finer resolutions? This paradoxical property arises from the fractal nature of natural shapes. The infinite universe. The universe is finite. What lies beyond its edge? In Guatemala de Crula, If the universe is infinite, it implies that there are infinite versions of ourselves. But if the universe is finite, what lies beyond its edge? Philosophical reflections on infinity. Infinity is not just a mathematical or scientific concept. It is a profound philosophical challenge that forces us to confront the limits of human understanding. Can we comprehend the infinite? Infinity stretches beyond the boundaries of our perception and imagination. While we can describe it mathematically, truly grasping its nature may be beyond our cognitive abilities. Infinity and the nature of existence. The paradox of the infinite raises questions about the nature of reality. Is the universe truly infinite, or is infinity an abstract construct that exists only in our minds? If infinity exists, what does it mean for our finite lives and experiences? The mystery of the infinite infinity invites us to embrace the unknown. It reminds us that some truths may always elude us, leaving room for wonder and exploration. Reflections on the infinite. The paradox of the infinite is a reminder that the universe is both vast and intimate, boundless and precise. It challenges us to think beyond the constraints of logic and intuition, exploring the mysteries at the edge of understanding. As we continue our journey through paradoxes, let us carry with us the lessons of infinity. Some questions may never have definitive answers, but pursuing those answers enriches our understanding of existence. The paradox of the unexpected hanging. Can the unpredictable be predicted? Imagine being told you'll face an event that will take you by surprise, but also be assured that it will happen within a specific time frame. You begin analyzing the situation, trying to outsmart the inevitability of surprise. As you reason through the possibilities, the problem becomes more confusing, not less. This is the essence of the unexpected hanging paradox, a logical puzzle that confounds our understanding of surprise, prediction, and reasoning. The paradox presents a seemingly straightforward scenario that spirals into contradiction, challenging how we think about knowledge and anticipation. The paradox explained. The unexpected hanging paradox begins with a judge issuing a peculiar sentence. The prisoner will be hanged at noon on one weekday, Monday through Friday. The execution will be a surprise, meaning the prisoner will not know the day in advance. At first, the conditions seem straightforward, but contradictions emerge as the prisoner begins to think through the situation, reasoning through the paradox. If the hanging is to be a surprise, it cannot happen on Friday. Why? By Thursday evening, the prisoner would know it must happen the next day, eliminating the element of surprise. The hanging cannot happen on Thursday if Friday is ruled out. The prisoner would know it must occur on Thursday by Wednesday evening, making it predictable. Continuing this logic, the prisoner eliminates each day of the week, concluding that the hanging cannot happen at all. The twist. Despite this reasoning, the hanging occurs on a random day, perhaps Wednesday, and catches the prisoner entirely off guard. The conditions of the sentence are fulfilled, leaving the prisoner, and us, puzzled about where their reasoning went wrong. The core contradiction, knowledge versus surprise. The unexpected hanging paradox hinges on the interplay between knowledge and surprise. The prisoner's attempt to predict the unpredictable creates a logical conflict. The nature of surprise. For an event to be a surprise, it must defy anticipation. However, the prisoner's reasoning attempts to eliminate the possibility of surprise by considering every scenario. This creates a feedback loop. The more the prisoner analyzes the situation, the more they undermine their expectations. Logical circularity. The paradox reveals a circular problem. The prisoner's reasoning affirms and denies the possibility of a surprise hanging. This circularity mirrors other paradoxes, such as the liar paradox, where truth and falsehood become entangled. Applications and variations. The unexpected hanging paradox has broader applications beyond its original formulation, appearing in various fields and everyday situations. Surprise quizzes. Teachers often announce that a quiz will be given on an unexpected day. Like the prisoner, students try to predict the timing, often to no avail. The paradox highlights the tension between preparation and unpredictability. Military strategy. In warfare, surprise is a key element of strategy. Commanders plan ambushes that defy enemy expectations, creating a real-world parallel to the paradox. The unpredictability of attacks forces adversaries to anticipate the unexpected, mirroring the prisoner's dilemma constantly. Game theory and decision-making. The paradox has implications for game theory, where players must balance prediction and unpredictability. In competitive scenarios, maintaining an element of surprise can be a powerful tactic, forcing opponents into uncertainty. Philosophical implications. Beyond its practical applications, the unexpected hanging paradox raises profound philosophical questions about knowledge, time, and the limits of human reasoning. Can knowledge be complete? The paradox suggests that knowledge is inherently limited. The prisoner's attempt to predict the hanging highlights the impossibility of knowing everything in advance. This aligns with broader philosophical ideas about uncertainty and the unknowable nature of the future. The role of time in paradoxes. Time plays a central role in the paradox. The prisoner's reasoning unfolds sequentially, but the surprise hinges on disrupting this sequence. This tension between linear reasoning and temporal unpredictability reflects the complexity of time as a concept. The limits of logic. The paradox reveals the limitations of logical reasoning when applied to specific scenarios. It shows that even the most rigorous analysis can lead to contradictions, forcing us to reconsider the boundaries of rational thought. Reflections on the unexpected hanging. The unexpected hanging paradox is a reminder that life is full of surprises, some planned, others inevitable. It challenges us to embrace uncertainty and accept that not everything can be predicted or controlled. As we continue exploring paradoxes, let us carry with us the lessons of this riddle, that the unexpected is not a flaw in reasoning, but a fundamental part of existence, inviting us to live with curiosity, humility, and openness to the unknown. The Sorites paradox. When does a heap stop being a heap? When does a collection of grains of sand become a heap? If you remove one grain, is it still a heap? What if you remove another? At what point does it cease to be a heap altogether? This is the Sorites paradox, also known as the paradox of the heap. Its name comes from the Greek word soros, meaning heap. On the surface, the paradox appears deceptively simple, but its implications extend far beyond sand piles, touching on language, logic, and the nature of definitions. The Sorites paradox challenges us to confront the vagueness inherent in many concepts. It reveals that the boundaries we take for granted between heaps and non-heaps, baldness and hairiness, or even day and night, are often more fluid and subjective than we realize. The core of the paradox, vagueness and gradual change. At its heart, the Sorites paradox arises from vagueness, the lack of precise boundaries in how we define certain concepts. The thought experiment. Start with a heap of sand. Remove one grain. It's still a heap, right? Remove another grain. It's still a heap. Repeat this process, and eventually you're left with a single grain. But can a single grain be a heap? If not, at what exact point did it stop being one? The contradiction, the paradox reveals a contradiction between our intuitive understanding of heap and the logic of gradual change. If removing one grain doesn't change the heaps, then no single grain can make the difference. Yet, by eliminating enough grains, the heap eventually disappears. The problem of vagueness. The Sorites paradox highlights the problem of vagueness in language. Many everyday concepts, heap, tall, rich, old, lack clear-cut boundaries, leading to ambiguity and contradiction. Applications of the paradox. The Sorites paradox is not just an abstract puzzle, it has profound implications for how we navigate the world. Language and definitions. Everyday language is full of vague terms. For example, at what point does a tall person become very tall? The paradox forces us to consider whether vague terms can ever have precise definitions, or whether vagueness is an unavoidable feature of communication. Ethics and policy. In ethics, the Sorites paradox arises in debates about thresholds. For instance, how much suffering makes an act immoral? At what point does economic inequality become unacceptable? In public policy, the paradox appears in discussions of thresholds for benefits, taxes, and legal categories such as poverty or disability. Philosophy and identity. The paradox also touches on questions of identity and continuity. For example, if a person changes gradually over time, are they still the same individual? Philosophical responses to the Sorites paradox. Philosophers have proposed various strategies to address the Sorites paradox, each offering a unique vagueness and gradual change perspective. Sharp boundaries. One approach is to argue that there are precise boundaries, even if we don't know them. For example, a specific number of grains might define a heap, even if it's challenging to identify. Critics argue this solution feels arbitrary, imposing artificial precision on inherently vague concepts. Fuzzy logic. Fuzzy logic offers an alternative by allowing for degrees of truth. Instead of saying heap or not a heap, we can assign a percentage of heapness to each stage of the process. This approach aligns with how humans often think, acknowledging shades of gray rather than binary distinctions. Contextualism. Contextualism suggests that the meaning of vague terms depends on the context in which they are used. For example, a small pile of sand might be a heap in one situation but not in another. This view emphasizes the flexibility and adaptability of language. Epistemicism. Epistemicists argue that vague terms have precise boundaries, but we lack the knowledge to determine them. For example, there might be an exact point at which a heap ceases to be a heap, even if we can't identify it. The broader implications of vagueness. The Sorites paradox extends beyond language, touching on more profound questions about the nature of reality and human perception. Continuity in nature. The paradox reflects the continuity of natural processes. Change often occurs gradually in nature, without clear-cut transitions. For example, when does night become day? When does a seedling become a tree? These transitions are gradual and defy precise categorization. The limits of human perception. The Sorites paradox highlights the limitations of our perception and reasoning. We tend to think in categories, but reality often exists on a spectrum. This gap between perception and reality creates ambiguity, forcing us to navigate uncertainty in our understanding of the world. The complexity of definitions. The paradox reminds us that definitions are tools, not absolute truths. They help us communicate and make sense of the world, but are inherently imperfect. Reflections on the Sorites paradox. The Sorites paradox is a testament to the complexity and subtlety of our world. It reveals that even the most straightforward concepts, like a heap of sand, are fraught with ambiguity and nuance. As we continue our exploration of paradoxes, let us carry with us the lessons of the Sorites paradox, that the world is not always as clear-cut as it seems, and that embracing vagueness can lead to a deeper understanding and appreciation of life's subtleties. The paradox of Theseus' ship. What defines identity? If something is gradually replaced piece by piece, at what point does it become something new? This is the heart of the ship of Theseus paradox, an ancient philosophical puzzle that challenges our understanding of identity, continuity, and transformation. The paradox is more than just a question about ships. It applies to everything around us. If every cell in your body is replaced over time, are you still the same person? If a book's pages are replaced one by one, is it still the same book? Does identity lie in physical components, or is it something deeper? The ship of Theseus forces us to grapple with fundamental questions about existence, selfhood, and the passage of time. The paradox unveiled. The ship that rebuilt itself. The ship of Theseus paradox is attributed to the Greek historian Plutarch, who posed the question, if a ship has all its wooden planks replaced over time, is it still the same ship? If not, when did it stop being the original ship? The paradox emerges because two conflicting ideas about identity clash. The identity of continuity. One argument states that as long as the ship maintains its form and function, it remains the same. This view emphasizes continuity. The ship is the same because it retains its purpose and historical connection, the identity of composition. Another perspective argues that the ship is defined by its physical materials. If every part has been replaced, it is no longer the same ship. This view suggests that identity is tied to substance rather than history. The paradox becomes even more complex when we introduce a new twist. What if the old, discarded planks were gathered and used to build another ship? Now we have two ships, one with all new parts but historical continuity, and another made entirely of the original materials. Which one is the real ship of Theseus? Real-world applications of the paradox. The ship of Theseus is not just a thought experiment. It has profound implications in many fields: personal identity and the human body. Did you know that nearly every cell in your body is replaced over time? Scientists estimate that within a decade, most of the cells that make up you are new. If your body is constantly regenerating, are you still the same person you were 10 years ago? Technology and artificial intelligence. In robotics and AI, machines are repaired and upgraded constantly. If an AI is transferred to a new system with updated hardware but retains its knowledge, is it still the same entity? If consciousness were uploaded to a digital system, would the copy indeed be you? Cultural and historical identity. Many historical artifacts and buildings undergo restoration. If the Mona Lisa had been gradually repainted over centuries, would it still be the Mona Lisa? If a city rebuilds after destruction, does it retain its original identity, or has it become something new? The philosophy of self, memory, personality, and experiences shape our identity. But what happens if those change? If a person suffers amnesia or a radical personality shift, are they still the same individual? Philosophical responses to the paradox. Philosophers have approached the ship of Theseus paradox from various angles, each offering a unique perspective on identity. The continuity theory. This theory states that identity persists as long as there is an unbroken chain of existence. Even if physical parts change, the ship remains the same because its history connects it to its original state. The materialist view. This view argues that identity is tied to physical composition. Once the materials change, the object becomes something new. Under this perspective, the new ship built from the old parts would be the authentic ship of Theseus. The psychological view. For humans. Applied to people, this view suggests that identity is based on memory and consciousness rather than physical continuity. If someone's memories and personality remain intact, they are still the same person, even if their body changes. The dual ship solution. Some propose that identity is not binary. It is not a question of same or different, but rather a spectrum. Both the restored ship and the reconstructed ship could be considered versions of the original. The broader meaning of identity and change. The ship of Theseus reminds us that change is inevitable. Whether we are discussing objects, societies, or ourselves, everything is in a state of transformation. The illusion of permanence. The paradox challenges the idea that things remain static. Even when something appears unchanging, it is constantly evolving. The fluidity of identity. Identity is not a fixed state. It is dynamic. It is shaped by continuity, memory, and context. Perhaps identity is less about absolute sameness and more about our stories. The comfort of change. Though the paradox raises profound questions, it also offers a reassuring message. 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 The paradox raises profound questions. It also offers a reassuring message. The paradox raises profound questions. It also offers a reassuring message. The paradox raises profound questions. It also offers a reassuring message. The paradox raises profound questions. It also offers a reassuring message. The paradox raises whether we consider ourselves the same person over time or evolving beings. The journey gives us continuity. Reflections on the ship of Theseus. The ship of Theseus paradox concerns more than wooden planks or ancient vessels. It reflects the fundamental mystery of identity and asks us to reconsider how we define ourselves, our creations, and our world. As we continue exploring paradoxes, let us carry with us the lesson of Theseus's ship, that identity is not found in stillness but in change, and that even as we evolve, the essence of who we are remains in the stories we tell and the journeys we take. Maxwell's demon: can we cheat the laws of physics? For centuries, humanity has sought ways to control nature, to harness fire, tame electricity, and manipulate matter itself. But what if there were a way to break one of the fundamental laws of physics? This is the essence of Maxwell's demon, a thought experiment proposed by the Scottish physicist James Clerk Maxwell in 1867. It presents a scenario where an intelligent being, no more significant than an atom, could seemingly defy the second law of thermodynamics, a principle that dictates the inevitable increase of disorder or entropy in any closed system. If Maxwell's demon could exist, it would mean that energy could be rearranged in a way that defies natural decay. It would imply that heat could be controlled without work, allowing perpetual motion machines to be possible. Machines that could run forever without needing energy input. In short, Maxwell's demon threatens to overturn our very understanding of how the universe works. But is such a thing truly possible? Or does the paradox reveal something even more profound about the nature of reality? The setup: a microscopic gatekeeper. Maxwell imagined a box filled with gas molecules at a uniform temperature. This means that, on average, the molecules are moving at similar speeds, bouncing around chaotically. But what if a tiny demon could watch these molecules and selectively sort them? The demon's strategy. The demon monitors the gas molecules as they move randomly. When a fast-moving hot molecule approaches the door from the left side, the demon quickly opens the door, allowing it to pass into the right chamber. When a slow-moving cold molecule approaches from the right, the demon does the opposite. It lets it move to the left chamber. The paradoxical result: over time, the right side of the box accumulates faster, hotter molecules, while the left side becomes cooler. This creates a temperature difference without performing any work, a result that appears to contradict the second law of thermodynamics. According to physics, heat naturally flows from hot to cold, not the other way around. But in Maxwell's thought experiment, the demon seems to have reversed the natural flow of energy, allowing heat to concentrate in one place without expending energy, something that, in theory, should be impossible. If such a process were actual, we could create a perpetual motion machine, a system that could generate energy endlessly without needing an external power source. The consequences of this would be staggering. Infinite energy, no waste, and a complete rewriting of the laws of physics. But as tempting as this idea sounds, the question remains: can Maxwell's demon actually exist? The second law of thermodynamics: why disorder always wins. To understand why Maxwell's demon presents such a paradox, we must first understand the second law of thermodynamics. What is entropy? Entropy is a measure of disorder in a system. The second law states that, over time, any closed system will naturally become more disordered unless energy is added to maintain order. This is why hot coffee cools down, why stars burn out, and why life itself requires energy input to sustain itself. Why Maxwell's demon is a problem. In theory, energy should always spread out over time. Heat should flow naturally from hot regions to cold ones, balancing everything out. Maxwell's demon appears to create order out of disorder without doing any work, violating the core principle that entropy must always increase in a closed system. If Maxwell's demon were real, It would suggest that we could decrease entropy at will, meaning we could create endless energy with no input. This would challenge not just thermodynamics, but physics itself. Attempts to solve the paradox. For over a century, physicists debated Maxwell's demon, searching for an answer to why it shouldn't work. Several attempts have been made to resolve the paradox. Szilard's resolution, the cost of information. In the 1920s, physicist Leo Szilard proposed that the demon itself must gather information about each molecule before deciding when to open or close the door. This means the demon must store and process information, which requires energy. As a result, the demon itself produces entropy in the process of measuring molecules, canceling out the energy it appears to save. Landauer's principle, the hidden cost of memory. In the 1960s, physicist Rolf Landauer built on this idea, showing that the act of erasing information produces heat. The demon's memory must be erased periodically to continue sorting molecules, and this erasure process generates entropy. In other words, while the demon seems to cheat the system, the information processing required to do so ultimately restores the natural balance of entropy. Quantum mechanics and the demon. Some modern interpretations suggest that if Maxwell's demon were operating at a quantum level, strange effects like quantum tunneling and entanglement might come into play. In some interpretations of quantum mechanics, information is never truly lost. It is simply transformed into a different state. This could mean that Maxwell's demon does not actually break the second law, but rather exploits hidden features of the quantum world that we do not yet fully understand. What Maxwell's demon teaches us about reality. So, does Maxwell's demon indeed violate the laws of physics? The answer is no, because while the demon seems to create energy from nothing, the hidden cost of gathering and erasing information restores the balance of entropy. But this paradox taught us something even more profound. The deep connection between information and physics. The resolution of Maxwell's demon led to breakthroughs in information theory, revealing that knowledge, computation, and physics are deeply intertwined. Today, concepts like entropy in computing and data processing limits trace their origins back to this paradox. The unyielding laws of the universe, the second law of thermodynamics, remains undefeated. Entropy must always increase in a closed system. The dream of a perpetual motion machine remains impossible, at least as far as we know. The limits of human understanding, Maxwell's demon, reminds us that physics is not just about equations. It is about the hidden mechanisms that underpin reality. Even when we think we have found a loophole, deeper truths emerge, revealing the intricate design of the universe. Final reflection. The dance of order and chaos. Maxwell's demon is a paradox that dances on the edge of possibility and impossibility. It does not allow us to break the laws of physics, but it does reveal how deeply interconnected they are. And so, the question remains, are there still hidden loopholes in the laws of reality? Or is the universe, in all its vastness, bound by rules we have yet to understand fully? The Bootstrap paradox, the mystery of information without origin. What happens when something has no origin? When an idea, an object, or even a person exists in an endless loop, never created, never destroyed, only repeating through time? This is the essence of the Bootstrap paradox, one of the most perplexing paradoxes of time travel and causality. Unlike the grandfather paradox, which explores how time travel can disrupt the past, the Bootstrap paradox questions whether something can exist without ever having been created in the first place. It is a paradox of self-creation, where an event, object, or piece of information loops endlessly through time with no clear point of origin. But if something is never truly created, does it ever really exist at all? The paradox unfolds, a story with no beginning. The Bootstrap paradox is often illustrated through thought experiments involving famous works of literature, scientific discoveries, or historical figures. Imagine this. A time traveler from the future loves Shakespeare's works. Wanting to preserve them, they brought a complete collection of his plays back in time and gave them to a young William Shakespeare before he had written them. Shakespeare then copies the plays, word for word, claiming them as his own and publishing them. Centuries later, those same plays are printed in books, studied, and eventually end up in the hands of the same time traveler, who then takes them back in time to give to Shakespeare. This creates a causal loop, a closed cycle where the plays have no original author. Shakespeare never actually writes them. He only receives them from the future and copies them. But where did they come from in the first place? If information, knowledge, or an object is never created, only passed back and forth, does it really exist? Variations of the Bootstrap paradox, self-creation across time. The Bootstrap paradox is not limited to literature. It applies to objects, inventions, and even people. Some variations include the information paradox. A physicist discovers the equation for faster-than-light travel, claiming they found it in an old research paper. Years later, another scientist finds the same equation and publishes it, only for it to be rediscovered centuries later in the future. If the equation was never actually formulated by anyone, only passed forward through time, then who originally discovered it? The object paradox. A time traveler from the future finds a mysterious artifact. A watch, a piece of technology, or even a book. Wanting to preserve it, they take it back in time and leave it for someone to find. The artifact then remains in existence through time loops, never truly created, only existing. The human bootstrap paradox. A baby is abandoned on the steps of an orphanage, raised without knowing their origins. Years later, they accidentally travel back in time and become the person who leaves the baby at the orphanage. This means they are both their own parent and their own child, a person with no real beginning. The philosophy of causal loops. Can something exist without creation? The Bootstrap paradox forces us to question the nature of causality in existence. If something exists only because it was passed back through time, does it indeed exist? Can knowledge exist without discovery? If an equation, book, or piece of music is trapped in a time loop, does it ever have an original creator? Or is it simply knowledge that always existed, floating through time, waiting to be discovered? What defines an origin? We assume that everything has an origin, that for something to exist, it must have been created at some point. However, the Bootstrap paradox challenges this idea, suggesting that some things might exist outside the standard rules of cause and effect. Is the universe itself a Bootstrap paradox? Some scientists propose that the universe may be self-creating, that it exists because it caused itself to exist. Could the laws of physics, space, and time be part of a self-contained loop with no beginning and no end? Can the Bootstrap paradox be resolved? Can the Bootstrap paradox ever be resolved? Or is it an unsolvable mystery, one that forces us to question the fundamental nature of reality? One possibility: the loop must have started somewhere. Some argue that despite the illusion of self-containment, something must have started the loop. Even if an object, idea, or event is caught in a cycle, there must have been an initial point of creation that became lost in time. Another possibility: time may not work the way we think. If time is not truly linear, but more like a four-dimensional structure where past, present, and future coexist, then an event may not need a traditional cause. In this view, causal loops are simply part of the fabric of reality, and the paradox only exists because we expect time to have a clear beginning and end. Or, perhaps, some things simply have no origin. The Bootstrap paradox forces us to consider that some things may not need to be created in the way we assume. If an object, an idea, or even a person can be caught in a time looper, perhaps our entire understanding of causality is incomplete. Final thoughts. The loop that never ends. The Bootstrap paradox is one of the strangest contradictions in time travel, forcing us to ask whether knowledge, objects, or even people can exist without ever being created. It blurs the line between cause and effect, It challenges the fundamental nature of time, and it leaves us with the ultimate question: does everything need an origin? Perhaps the answer is hidden in time. As with all paradoxes, the mystery is the answer. Conclusion: the endless mystery of paradoxes. Paradoxes. At first, they seem like simple puzzles, curious contradictions that make us pause and think. But the deeper we look, the more they unravel the very foundation of our understanding. They expose the gaps in our logic, the limits of our knowledge, and the hidden complexity of reality itself. Throughout this journey, we have explored paradoxes that bend time, twist logic, defy mathematics, and question the nature of identity. Some have left us with unresolved contradictions, others with profound insights, and all have invited us to step beyond what we thought we knew. But now, as we stand at the end of this journey, one question lingers. What do paradoxes indeed mean? Are they flaws in human thought, evidence that our reasoning is imperfect, or are they whispers from the universe itself, hinting that reality is far stranger than we can yet comprehend? To answer this, let us take one final journey, through the paradoxes we have explored, through the mysteries that remain unanswered, and through the infinite unknown that still lies ahead. The journey through paradoxes. What have we discovered? Each paradox has shown us a different way reality refuses to conform to our expectations. Some have challenged our logic, some have questioned our understanding of time, and others have forced us to redefine existence itself. The paradoxes of truth and logic, the liar paradox. This statement is false, shattered our belief that truth is absolute. Russell's paradox. Does the set of all sets that do not contain themselves contain themselves? Revealed that even mathematics, the language of certainty, contains contradictions. These paradoxes force us to ask, can we ever trust logic completely? Or is reality itself paradoxical at its core? The paradoxes of time and causality. The grandfather paradox questioned whether the past can ever be changed, or if time itself is self-correcting. The Bootstrap paradox challenged us with objects, information, and even people who seem to exist without ever being created. These paradoxes ask, is time an unbreakable thread or a tangled web of loops and possibilities? The paradoxes of infinity and motion. Zeno's paradoxes suggested that motion is impossible and that Achilles can never catch the tortoise because an infinite number of steps separate them. The Sorites paradox, when does a heap stop being a heap, revealed the hidden vagueness of language, questioning whether anything can ever truly be defined. These paradoxes ask, is infinity a real thing, or just a trick of the mind? Can something even need to be distinct, or is all reality a blur? The paradoxes of identity and change, the ship of Theseus, forced us to ask, if every part of an object is replaced, is it still the same object? Maxwell's demon defied the laws of physics, suggesting that entropy, the fundamental rule of the universe, might not be as inevitable as we think. These paradoxes ask, what makes something itself? If we are constantly changing, are we ever the same person we were yesterday? The paradoxes of the cosmos, the Fermi paradox, where are the aliens, pointed to a contradiction between the vastness of space and the silence of the stars. The omnipotence paradox. Can an all-powerful being create a rock so heavy that they cannot lift it? Showed us that even infinity may have limits. These paradoxes ask, are there forces greater than logic itself? Are there truths beyond what we can ever perceive? Each paradox has left us not with answers but with more profound questions. They remind us that the universe is not simple. It is vast, infinite, and beyond our current understanding. But perhaps this is the true purpose of paradoxes, not to be solved, but to keep us searching. What do paradoxes teach us? Paradoxes are not mistakes. They are signposts. They point to the places where human knowledge meets its limits. They are the edges of the map, where certainty fades into mystery. They remind us that truth is not straightforward or simple, Some questions may never have definite answers. Reality does not always fit into neat, logical categories. Our perception is incomplete. We see time as linear, yet paradoxes suggest it may be more complex. We define identity rigidly, yet paradoxes reveal that everything is in flux. Mystery is not failure, it is the essence of discovery. Every paradox is a doorway to something greater. The moment we think we understand everything, paradoxes remind us that there is always more to learn. Paradoxes do not destroy knowledge, they expand it. They force us to rethink, to question, to look deeper. And in doing so, they reveal that understanding is not about having all the answers. It is about embracing the journey itself. Final reflection. The beauty of the unknown. We began this journey with a simple question. Why do paradoxes exist? And now, after all we have explored, we arrive at the only answer that truly matters. Paradoxes exist because reality is more complex, more beautiful, and more unknowable than we can yet comprehend. They remind us that curiosity is endless. No matter how much we learn, there will always be new questions, new mysteries, and new wonders waiting beyond the horizon. So, as we leave this journey behind, let us not search for absolute answers, but for better questions. Let us embrace the unknown, not as something to fear, but as the very essence of discovery. Because in the end, the greatest paradox of all is this: the more we learn, the more we realize how little we truly know.